Hello, hello. Welcome back to kottefolket gamedev log. We are currently in the aftermath of refactoring the player state machine stuff. And we've gotten basically almost everything over. I mean, yeah, there's some leftovers here. Maybe we'll just, because this is not really used anymore, so we should actually just remove this and find things like this where we have like special case stuff with the camera. I'm not sure if this is even used though. I guess it is, since it is called from here, and we are calling this from a bunch of places. Okay. Well, instead of doing this, we have to do actually, I'm gonna go ahead and add a function here. Is state and state is anything. Oh, okay, so this will simply call, well, okay. Well, I guess this could be an easy way to create the context, perhaps. Check the state. Yeah. The kind of bad thing about this is that our state machine probably would have been good to be like a tag union maybe instead. Oh man, that would change like everything though. Like, I'll use this all over the place now, so the cost of changing that would be quite high. Well, I mean, yeah, maybe probably take a day of refactoring that. But essentially, instead of having these as declarations, I would have a tag union instead with all the states. Instead of this being a struct, it would be a tag union. And so then the state would essentially be one of those. I'm not sure if that works though, because it would be like a mix of okay, actually, you know what, instead of having yeah what you could have, if I were to redesign this, I would probably do something like this. I would have the state machine be, so let's say my state machine. So this would be a union enum. And then you would have, let's do this at the bottom here so we can focus on this. So then you would have like, let's say initial, which is like a common for the initial state. And that will be, the problem here though is that this is usually just a function. It's kind of like we're mixing runtime and comp time stuff. But we could, but actually, I'm not sure. It's just the thing that I'm after is being able to have a implicit state or implicit declaration access or field access if it's a union enum. Like, that's what I'm after. Hello, I am the hunter. Did you see which how bun is made now? Hello, the procrastinator. All right. See you later. Thank you. So how Bun is made now? So I did see that it was rewritten in Rust with AI and passed like 98% of the tests or something like that. I haven't looked at it after that. Yo, Boro Checker, what's up? What's up? Karamelldansen. What? What are you talking about? 1 second. Yeah, I have no idea. Like I know what I mean. Karamelldansen is like isn't that like a old meme or something? Like a music thing? Is okay. I borrow a second. Is that like, you know, one of those where you try to kind of it's like they sing it in Swedish or something and then you misheard lyrics. Okay. Yeah, we have those as well, but for other things. Okay. I don't think I've ever listened to the thing, to be honest. Cat violating a handbag. Lisa humiliating Harry. Okay. All right. It's fun if maybe I can translate it back from that translation. Maybe I can like try to see what they were supposed to be in Swedish. Maybe not. Cat. No, I don't know. I don't know. I can't now. It's gonna sound weird as well. You know what? Never mind. I don't know. I was thinking something like you would have like a union enum that is like the state function is a union enum that is either an update function, and I guess this would be like this, or it would be I don't know, advanced, which then would have the pre function. But the problem is then these functions are like not defined here. I don't know. Because you can't, well, you can supply a function directly, but it's like ugly. No, this doesn't work. Okay, anyway, let's go back to here. So instead of doing this, we would get the state machine. Actually, let's just do this. Get state machine. No, because then we need T. Ah. What's happening? No, wait, no. What we do is we say song already sounds weird for non-natives. Yeah, but yeah, then it's gonna be me saying it. Is state, yes, and then init okay, it's a little bit more things happening here. I wish I could more easily do this one, but yeah. Do we need this now? No. Okay. Right, so let's go back to player and just check where else is this used. Debug. Draw combo input. Right. Well, we don't really use this anymore. So I'm just gonna comment this out. What the hell? Oh yeah. Oh shit. The boss. Right. I mean, maybe we should just have like player utils or something. Is player state. Let's just do that. Is player state. And the only thing we need really is registry, I believe. And then the state. Actually, this could be like a union. This could be the field enum of the player state. No, not field enum, declaration enum. Okay, it won't get auto completed, but it will get compilation error. Oh shit, sorry about that. 1 second. Oops. By the way, do you know if there's if it's like easy to set up like alerts for, you know, getting raids or stuff like that? Because I have nothing right now. Because I noticed that once it happens to other people, it's always the same sound effects. Yeah, thanks. Okay, cool. Yeah, I'll check it out. Thanks. Nice, nice. It's weird because it happens like once a day or something like that. Every time it happens like once a stream. Actually, whatever. Let's see. Okay, so this will do. So this will do. So first we need the context. So basically we need to do like is state init, and then we have registry. I think we also need game. Wait, I'm pretty sure we have like get game somewhere. Oh, just utils, okay. Okay, because now we can say game player and game t, and then not state, but we will do at field. So player state and this needs to be com time actually. So field of player state machine using tag name state. That's the state we want to check. There we go. Okay, and now now we can say if is player state and the state is hurt. Now we can just say dot hurt here because it's a declaration enum, and that should work as well. Should work. And actually, yeah, here we're stunning this thing, but actually, I mean, I guess we could set I just realized something actually. The duration of the state actually is pretty rigid with my new system. unless you can, well, I mean, you can get around it. But usually I just set some, because this is used as a stun. And essentially it's infinite here, so we have to invent a new way of doing this, I think. Okay, first of all, I think what we want to do is we want to probably expose like a function here, like stun player or something. Actually, we probably only need the registry. And then duration. No. So this will be well, let's get the context. And yeah, and then we need some kind of mechanism now for doing that. So I mean, we could set the state to a stunned state or a hurt or the hurt state. Trouble is we don't have a way of like setting the duration really. But what we can do is we can go to here and we can add like a stun duration here, or like stunned until or something like that, and use that as a duration when going into the hurt state. Hurt is kind of used now as both stun, and so that's fine. Which it does play this hurt sound, that's fine, I guess. So we don't set it to the end of animation. What we do is we I want to loop false. What we do is we check that's the thing. Probably maybe this will be optional, and then we have to clear it after. So we'll have a post. Oops. Where we set that to null, and here we check if we have stun until we get the thing, and otherwise to do this, here we set state duration to stunned until. Actually, this is the actual timer. Set state ends at. There we go. Yeah. Okay. And now we'll go back here and we'll say set state 2 Hz. Now we can set it multiple times. Although it's gonna play the sound every time if you have like something that's stunning a lot of times. Well, we'll get the problem when we get the problem. The new state is gonna be player state machine hurt. And before that, we get the player state. It's gonna be player state machine player. Well, actually, spot state. And now we need to set this before. So stun until is equal to yeah, now we can use this. No. Yes, we can. Create timer, and the duration will be the thing we put in here. There we go. Okay, so now we can go back here, and instead of doing all this crap, we can just say duration. Doesn't matter. I mean, it's infinite. So, and then we say stun player, and we don't even need, you know, this part now. Okay. And we don't need you either. There we go. Now end push player. This, yeah. Setting us back to idle. So we could do that. We could also we could stun the player with 0 duration, perhaps, maybe. I don't know. Because that will make the state machine responsible what state to put us back in, and not this one. Well. Sure. I just realized also, like, if you get 2 stuns using this function, whatever stun is after will get priority. So even if you've stunned like 10 seconds first, and you get another stun which is like 1 second, that overwrites the previous stun. But yeah, that will be a future issue. If it's even gonna be an issue. Like, this is only used in the boss fight right now. Okay. Okay, let's continue here. So let's see where else this is used. Over here. Right, this is important as well. So we're checking if we're currently controlling the thing. If we are, then we don't stop that. So I think instead we can say is player state, and the state is control. Then, I mean, I think we could potentially do this, although we don't have the source. Well, we kind of do have the source. We could say control state is equal to, well, actually, let's get the player state. And then the source will be player state control. Wait, why does this not work? Oh, because we don't have player context. And we don't have game. And And now we have a control state, which has to be there, and then the source. And then we do an update. I mean, it should be safe to call this again with the same timestamp, because nothing really should update unless, you know, something logical changed like this. So it's probably safe to call this here. Because usually the state transitions are based on timers, and there's no other like side effects happening during that. So the side effects happen during transitions, mostly, probably always, mostly, or it's based on time. It's always based on time, I think. Unless it's this logical stuff, but then we want it to be immediate anyway. I mean, I don't think we have to do update here. This is gonna happen next frame anyway, so it doesn't really matter. Let's just keep it in and see. And then we got, yeah, this is just the old way of doing it. Yeah. Should probably have a way to get the player context. I mean, actually, we don't need. Actually, we could just do for entity game.player. Wait, do we even need player context? No, we don't. Well, anyway, there's so many ways to do the same thing. Yo, Penguin, what's up? What's up? I'm just gonna go and grab a glass of water. I'll be right back. Starting to get warm this season. Yo, procrastinator, welcome back. How's it going? What are you up to? All right. Actually, you know what? Why am I doing all this stuff? Let's see, we have the control state. Whenever this exits, nothing really happens, I guess. Oh, yeah, because it's the control. It's the steering wheel's responsibility of cleaning that up, I guess. Yeah, so that's what's happening there. And then we update, which should set the player state to a different thing, yeah. All right. You saw my first game, sent a video on Discord. Did you send it recently, or let's see? cat is going crazy here. Wants me to open the door or something. I don't know. Did you come out? Oh yeah. I saw the. It's like a bunch of taxis on the road. Yeah, it looks nice. I like the graphics. Oh yeah. Yeah, I mean, there's no one else who did it who posted recently, so. Oh, I see. It's like Frogger. Nice. Yeah. If you hear the sound of a bag, it's my cat who decided to live in one. That's the first time I actually did something. Oh yeah. Yeah. I mean, yeah, it looks really cool. It looks smooth. Nice. The art is mine. Okay, yeah. Well, using an asset pack is a good way to get started. Yeah. Yeah. He likes his bags. Well, now he's in like a cat candy bag, so that's why I don't keep them in here, because nej. Okay. All right. Yeah. Okay, yes, that was that. Really nice. Do you plan on adding more features, or like, you know, are you gonna jump on another project? What are you calling today? So today I'm working on my game, Kottefolket, the metroidvania, and I am I'm continuing with the kind of the refactoring aftermath here with the state machine stuff. So the player state was kept like this before, and I'm just going through all the references and switching it out for. Okay, here we also have like stun players, so I think this is only used from within here, so we could simply change this to use this function over here. Now, and we only need a registry, so there we go. And now we don't need T here. I'm just gonna do that. Yeah, I don't. Yeah, that's fine. Okay, so that was that. Oh, we have another place. If the player's already hurt. Yeah, this is only for the player, by the way. Damage on touch is like only really for the player. Which I guess is kind of rigid, but so here we'll check. I guess it's this is more like, okay, the invincibility frames, really. So I don't think we actually need this here. I guess if we're invincible, because this is doing things like checking shield blocking, like removing the entity if it's supposed to be destroyed because we are colliding with, like a projectile being collided with the player, let's say. If you're invincible, does the projectile just phase through the player, or does it be like, is it destroyed? You know, there's like subtleties like that. The Frogger thing was just a JS tutorial thing, and I'm currently learning Phase. Oh, nice. So yeah, I'm learning some more things before I jump into my personal project. Yeah. So what? Okay. So what was the? So you didn't use Phaser for the Frogger. Like, what did you use? Did you just use like Canvas and native JS or something? By the way, is your game available on wishlist? No, but there is a link where you can actually play it on the web. Like an older version. I have to fix it, the thing where you press space and it jumps to the bottom of the screen, at least on my browser. But JS means just. Oh, just a tutorial thing. Okay. But what? Okay, but I was asking, like, what engine did you use? I thought you meant JavaScript, to be honest. But okay, I see now. No worries, no worries. All right. Yeah, that's the thing. Because if this is happening from if you're invincible, you could, but whatever. Let's just check. Let's just do if has invincible player return. Okay. We still need the component, but we don't really need it here, so oops. We actually only need it over here. Okay, we'll do that instead. Oh, use Godot. Oh, nice. You must be living on a rock if you don't know JS means just. I mean, to be fair, in the programming world, JS is JavaScript. I mean, I don't think I've ever seen JS be used as just, but that's probably just because I'm old. Why not reduce the velocity by negative when someone clicks space, so the jump will work? Yeah, I just haven't fixed it. Like, you can, the velocity, like the problem is that the problem is the web page has this built-in functionality that when you press space, it like goes to the bottom or something. So you have to disable that in the web, in the page, or reorganize the layout. But yeah, I'll probably just disable that. I mean, I think, yeah, I think you just have to add. You probably just have to add like an event listener space and then prevent default. Like, okay. 1 second. So can you see this here? Let's just have it like this. Okay, this is the page, the web page. You can see it's on the web page here. Okay, so I can, you know, I can't jump. It's just that the page kind of scrolls down when you press space. So it's nothing to do with the actual game. It's the scroll bar that like scrolls down when you press space. But if you go in to here and you kind of look at, I guess, event listeners, well, there's a whole bunch of shit in here. I mean, yeah, you just have to, I don't think you can, maybe you can't disable this from here. I actually don't know. Yeah, this is probably just, I don't know where this is coming from, but essentially it's just a browser thing. Yeah. Yeah, I'm gonna do it. I just haven't done it yet. Because I need to go into I need to like update the page and everything. I probably, oh, yeah. Anyway, there we go. So now that one is done. It's gonna take me like forever to do all this crap here. The input update is actually not, like, we could probably just remove all this thing, everything happening in here. So I'm just gonna do this, and then we'll be happy there. Yeah, I think we've done everything here, except for combo, which we don't really use. Yeah, I think we've done everything here. Yeah. All right. Cool. So now there's a lot less stuff, and most of it is from the within here. What the hell? Oh, I missed this part. I think we can just remove this, probably. Yeah, I think this could just be removed. Because we are like we're calling this from the states that need it. Yeah. Anyway, if it becomes a problem, we'll notice it. Okay, there we go. Input is lunch and input on. Okay, this is not really used anymore, so I'm just gonna do this. Get new camera elevation. I'm not sure if this is even used. I guess it is. All right. So if we're climbing, we have the ladder. Okay. Okay, this should be a function actually. Get elevation base entity. If this is true, we'll return climb B. I guess if it doesn't exist, we'll just return the player. Otherwise, we'll return the player. There we go. And now elevation base entity is that. Yes. All right. Cool. That was that. Oh yeah, this one is also not used. So I'll just remove it. Okay, now everything else is like from within here. So I think we can just remove this now. I'll do that. I'll keep it around just in case. This is also interesting, like if we set the state to attack, we have these things, but these things we don't need anymore. This thing I think we already moved over, so that should be fine. Okay, do we have anything else for state? Yeah. We have the hitbox, which depends on the duck state. This is kind of interesting. I'm thinking maybe. I mean, we could just use his player state here. Well, if it's not. can move. I don't think this is even called, so I'll just remove that. This one also, let's check. No. Oops. Wait. No. GCAP. There we go. Can charge. Start charge, stop charge, is charge full, charge ratio. Oh, let's see. Get attack damage. Well, we probably want that. Yeah, we still want this, but we could probably move it, but yeah, let's keep it around for now. And here's the player state thing, which we can just remove all this crap. Yeah. Player state focus. Yeah, control mist. The mist, though, I think the mist we actually want to have. Oh yeah, we didn't actually. Wait, is the mist an actual state? No, it's not. So we do want to keep the mist because the mist is like a separate state. It's a parallel state, yeah. So we want to keep that. Well, I'm gonna rename it. Yeah, so we don't need these. I think we need you. These we do need, I believe. Yeah, there's a lot of shit in here. Player state, less attack type. Yeah, these we don't want. We don't need you. Do we need this? I don't think so. Don't think we need this. This one we are using. And this one. Yeah. This one we are using as well. I mean, we can move it to the other place though. So we have everything in one place. I'll probably get rid of this play component, maybe. Maybe not. Whoops. I'm always a bit iffy when doing these LSP based renames because sometimes it feels like it doesn't actually work properly. like, I see some error messages when doing this as well. Oh yeah, the attack type we actually do want to keep, but I'm probably just gonna move it out to somewhere else. So basically we just move it over here. There we go. And then we can just refer it like this. And we probably have... Oh. Okay, I mean, yeah, the LSP doesn't report any errors, but I'm pretty sure we should have a bunch of errors now. So let's try and start this. It will be a miracle if we didn't have any errors. Okay, here we go. Camera. Expected optional type. So you are not an optional type. You are an optional type. Oh yeah, because we unwrap it, sorry. There we go. We were not supposed to do that. 135, attack type, right, so now, maybe we'll just put it here, maybe. Feels wrong, but whatever. Wait, no, that's not correct. There we go. That start frame, is that even called now? No. Attack type should probably do a search for attack type. Here. Right. But this doesn't matter. We still want to do these things actually. Update attack, I'm not sure. No, we don't want to do that. So we don't want to do that. Also, we don't really use state, so yeah. We do want to keep these things though, but they probably, yeah, we probably want to move this over as well to the state machine system, but one thing at a time. There we go. I think it went through maybe. Yeah. Cool. Okay. Now there is there's a conundrum with this game. And it's kind of like the aesthetic, as you can see, is like very 8-bit. The resolution is quite low. There's, you know, pixels are large. Now writing text, you can see this text here is like the pixels are actually smaller than the pixels. It's like 1/4 of the actual pixels here, I believe. Something like that anyway. It's smaller anyway. When you go into this here, these are actually, I believe, the same size now. They are a little bit anti-aliased, but I have a solution for that I'm gonna try out at some point. But you see, the dialogue, I mean, it takes up the entire screen. So I have to kind of think about, okay, how can we fix this issue here? Maybe we could just make this transparent or something. Or make it like smaller. I don't know. Because I have like a talking animation. It would be nice to see the actual characters that you're talking with at the same time. I mean, yeah, we could try maybe transparent background or something. Or, yeah. So that's one thing. Why did you change direction? Is it because I entered from there? Alright, cool. So we've gotten rid of the state now for the play component. So this whole old state system is now fully moved to the new system. So I think we can just remove all this crap now. Which is really nice. We could probably keep this one to use later. But yeah, there's really nothing left here. It's if we want to take back the combo, but that's easy enough to implement. Okay, was there anything else? We have like the dialogue and the menu stuff. But that's, yeah, I'm probably not gonna touch that. And here's the player system as well. That's right, so we can just remove this. Yeah, all of this can just be moved into the state machine system. And you are not used. There we go. Also this thing. could probably just call this actually. That's the easiest solution here. I was thinking of putting this in the state machine, but there's a problem with timing. I'll just put this in. Yeah, we don't do this one anymore. Good. But we do want to do that. It's like a special check happening after or just before the health system, so that we can do stuff depending on if we take, like, if we're going to take damage. Which, for example, here we're deactivating miss state. No, actually, wait, didn't we fix this already? Yeah, I think I fixed it with event hooks, actually. On damaged. Yeah. So we already do this. Oh, yeah. So we can just remove this. I've totally forgot about that. So we can just remove this whole thing. Boom. Cool. All right. Okay. Cool. Hurt duration. Let's remove that. Charge time. Want to keep this. Whoops. Okay. Yeah, so the rest of this stuff, we can like move this eventually into the new system. There's not much that much left, so but it's just I mean, maybe we'll just do it to have it done. But it's gonna be like all of this as well then, the player system. I mean, really, this is just getting. This is not really anything to do with the player system here. We can actually just move this out. It doesn't actually need to be in the system itself. Oops. Same with this thing. Come on. Check if that, like, nothing really needs, like, it's the update function. And check if that is, it's already a function. Where is it though? Is that, but it's in monster utils. That's weird. Yeah, it should be moved, to be honest, but that's already a thing, so we don't really need that. Essentially, the idea is the state machines will replace all this. All right, this updates the activation target. Is activatable. This function can be moved out as well. Find nearest. Basically, only the update functions should be in here. Okay, there we go. I'm gonna move you up here. All right. Yeah. Because this is like a separate state machine, sort of. That's the problem. Like, it would be really cool if we could have multiple state machines on one entity. I have to figure out a way to do that. Maybe we... The problem is the system will only look at entities. Like the entity system, the entity component system is based on like the like unique types. So if you have a generic state machine thing, it's gonna look at hang on. Yeah, because we add... Wait. This is the component that we're adding. Right, and you can't, in this system, you can't have multiple state machines. Unless we like unless we make it so that the state machine could potentially have multiple states within it. So instead of having one state, we can have like a hash map where you would tag, each state would have a tag. So you would have like the main state or whatever, and then the player would have like a main state, and then it would have like separate states, like the missed state, maybe. So if you initialize it normally here, we would just initialize it with one main state. But then you could potentially have more states if we change the inner workings of this. I don't think we need to change too much if we change this in internal logic here. Hopefully. I could try that, because that would really help. That would be really cool, actually, if we could do that. So, and then post would have to have the exact same structure, because that is also tied to one of the, like essentially everything in here. Like enabled is, I don't even know if that's even used. Like, are we even using these? I don't think so. Oh, I guess we are. Spawner and shooter. I guess we could add maybe add a tag argument that the default would be the main tag, or maybe default. Yeah, I think that's probably a really nice upgrade. Then we can do a lot of more stuff. And yeah, even the charge thing could also be really, yeah, I think this is actually pretty cool. I'm gonna have to think about it. I'm gonna have to, well, we're gonna have to test it out to see if it's good. I'm probably gonna do it like, I'll implement it, see how difficult it is, and then implement it from like a player perspective with the mist and charge states. They would be two separate things that is like parallel to the main state. Yeah, that sounds good. All right, I'll just have to BRB for 1 second here. Be right back. All right, I'm back. Okay. Yeah, so I think, okay, first of all, I'm just gonna try and run again. Okay, we do have issues. $143 hitbox. Oh. Okay, I'll just import this manually for now. Okay. I mean, I guess one thing that you kind of lose for having multiple states is that, or state machines, is like, I mean, it makes sense from like a state perspective that you would have multiple. Like, that's one perspective. But it does make it so that you can't go no longer like in here, go to the, for example, the idle state, and then everything that's in here is what could happen if when you're like in the idle state. So you kind of lose that by doing it, but I mean, it's kind of like that now anyways. Like, yeah, because the mist stuff is in the player system right now. For example, and these, yeah, I mean, it's kind of just like a separate state that is updated at all times. So it is functioning right now as a separate state machine. Yeah. Okay, let's just do it and see. Okay, so essentially, instead of having just one state function, we'll have multiple. And I guess the order, so they could be a hash map arrays, which would mean like the order in which they are added, that's the order in which they will be also evaluated as well. So this would be array hash map. We could use like a string, you could use auto with an enum. Why is there an equal string function here? Because this is how I would usually do it, like standard memory dot equal u8ab. Okay. Anyway, I guess it would be like auto, and then this will be... No, it has to be a string because we don't know what the enum will be. Okay, another way to do it is to do this very complex comp time structure that will kind of produce a bunch of different state machine types with corresponding state machine systems, where each of them matches one of the tags. That's also a way to do it, but then I think that will like copy all of the functionality and everything. But yeah. No, this is probably better here. Yeah, let's just make a string. We'll make string here instead. And then you will be a state function. And here's the same thing. Well, actually, it's probably better to have them as one thing. I mean, okay, let's make state machine internal or something. Those will be these. And then this will be states, where this will be a state machine internal. There we go. And then enabled could also be probably up here as well. And we can move, well, let's put these here as well. And here we'll add a tag. Because what I'm thinking is like we're gonna use tags instead of... No, it's not gonna be comp time known anyway. So I guess it has to be a string. Let's call it key, and then state machine key. It's just gonna be a string. I believe this will be this will kind of be the same thing, because this evaluates to a string, and then auto will kind of pick up that it's a string, and it will essentially just be a string hash map. I'm pretty sure it's gonna be like, well, okay, it's gonna create this hash map, but the context will use these functions. Actually, maybe not. String context, hash string. I mean, it probably will evaluate to the same thing. Anyway. Okay, and then, well, let's remove that, perhaps. You know what? We could have a filter here, actually, instead of a thing. So this would be like a key filter, which is either gonna be a tag or a key, state machine key, or it's gonna be all. And then we'll have a function that is like I guess key the naming here is, and like I would like this to be named key, but it's it can't because it's a shadowing here. So even if we try to do something like this, I'm gonna get an error here. So get an error there. Yeah, duplicate. So so you have to kind of, either you could do like init key, but that does, I don't like that. I like having this, and then you could do like this or something, but that also looks weird, but whatever, let's just do that. Fine. Are you serious? Okay. I mean, yeah, the shadowing thing is like, it leads to issues like this, which I don't like, because I would like to be able to say here dot key. I mean, we could name this something else. It's just annoying sometimes. But yeah, anyway. So now you are a state machine key filter. There we go. And what we do then is we can have a filter. We can have an iterator actually. So a filter iterator. Which gives us a machine internal pointer and I guess we need like an index. Actually, let's do that. All right, I'm not sure if this is copyable actually. Okay, so if index is null, actually let's do this. We get index. If this is null, we return null. Okay. And then we check, we switch on selector or the filter or whatever. Let's do filter. If the filter is all, I mean, we could do, or we could just do two different things. Like this is the all filter. So we'll check self index. Actually, you know what? I think we have to do this if we want to like have a pointer to index so we can actually modify it. And then we say index equals, well, plus equals 1. We also have to check here if index is more than or equal to state machine states count, then we set index to null. Well, actually we have to set self index to null and then return null. Okay, there we go. Otherwise we will return states values index. Right? Actually, it needs to be a pointer, so there we go. Okay, that's that. And then we have the other iterator, which is... No, actually... the iterator needs to be... No, that's fine. And then we have the key iterator, where we should just have a key here. No, not a filter, it's the key. And then we simply say get pointer key. And then we needed like a flag to say if we actually have the thing or not. have we gotten it? Consumed, I guess. If terminal all right. State machine key. Whoops. Add a init function here as well. State machine. Yeah, that's the only thing we need. Okay. So here we need an iterator. Actually, it needs to be mutable. So, well, actually, yeah, we could, if we move these out to the filters somewhere there. And then we'll say iterator. Now here's the tricky part, because this could be like two different iterators. So what you could do is say filter iterator is a union enum, where either you have key, oops, which is a filter key iterator, or you have all, which is filter all iterator. And now you have the next function here, which returns switch on self inline else. Excuse me. Next. And now this one would return a filter iterator. And we also need self. So if we're a key, we get the key and we return a filter iterator dot. Well, actually, we could just return dot key equals key or init. Actually, we need a state machine as well after that, and then the key. Why is this unknown? Oh, there we go. And of course, we have to do that. All right, and then we have all as well. There we go. Except you are not the thing. Cool. There we go. So now we have those. And now we can create the iterator. And we can say iterator self. And we can say while iterator next. We get a state thing. We don't need to do that. Okay. And then we get. Then we say, wait, where's the functions? Oh, hang on. the functions, we need to update the type here. There we go. Now we can say enable, and there we go. And we'll do the same thing here. Okay. I mean, we probably could have done this quicker with very specialized things, maybe. But it's fun to do these iterators and this kind of generic stuff sometimes. I don't know. I just get a kick out of doing stuff like that. Okay. Especially like in areas that is like very generic inherently. Like this could be used by anything, any entity basically in the thing. So you gain a lot also by doing these things at this like in this place. Sometimes, you know, if you don't know really what abstraction you need, then you probably don't. Then it's probably a bad idea to try to do something. But you know, you live, you learn, you make mistakes, you learn from them. Otherwise, you don't learn and you don't progress. So. Anyway. We have our little iterators. We have the state machine now have the states as a hash map, array hash map instead of just one. Our enable and disable functions now have a filter that we can use. So let's see how we can use it. So here, for example, now you also need a filter. So we have to pass that along here. And actually, this should also have a filter, I just realized. And we'll just pass this along. But let's see where this is actually used. It's used over here. And now instead of doing this, what we'll do is I'm just gonna say .all, which will, you know, be the same thing as it was before. I mean, it would be nice if that was kind of the default, that you didn't have to change anything here, but yeah. Okay. Right, and now the thing now that I'm kind of thinking about is since we already have a lot of stuff in place, I probably don't want to update all of the functions to now include a filter. Instead, I probably want to create separate functions if you want to target a specific key, and otherwise it will just target like the default state, or just all states maybe. No, it's probably better with just doing the default. I think also probably we want to say, okay, what is the default state? Like what string should that have? I mean, it could be default, could just be default. So it's like if you you add a new state machine, or you set the state, when we set the state, it's like we need to now target a specific state machine. Which is this one. So which state will that be? I mean, that will be the default state machine. No, actually, this is the collection of states. Yeah. So, but all things happening down here should be happening for one of the states. So I'm gonna make a separate function here. Set state for key. Key is state machine key, not filter, it's just a key. Okay, and then essentially we're just going to do all this. Yeah, we can validate the state as well. Except here we're going to say state machine internal is going to be this states get pointer to the key. If this isn't found, that's going to be an issue. I guess we just return. If that's not found, it's probably, we probably want to panic if it's not found, actually. And state machine internal key. State machine internal not found for key. And well, I mean, we need to actually, do we add a print to this? No. Okay, so we have that now, and then we do this instead. Okay. Actually, is enabled with filter is kind of weird. We probably just need a key here. Oh yeah, and then this one will just be set state 4 key. There we go. Actually, yeah, and then the key will be like default key. Oops. State machine by key. Should really be called get state machine. But. And then there we go. Is this used? Yes. Oof. Do we want to just add null here? Like optional, and if it's optional, we use the default key. Now we have to add null everywhere. Or we can say, actually we could just say this is enabled by key default key. There we go. All right. I'll try to make this work. We'll try this out with the well, first of all, we're gonna make this work with the things we have, but then I may try out with the mist form because it's pretty simple state to implement, and then we'll call it here. Okay, so now we don't need to do a whole bunch of fixes here. We could do the same for enable and disable, to be honest. By filter. And then enable is simply going to be key equals default key. See how easy it is to do that? That's why I want this. That's why I want this name of this to be just short, like key, instead of .init key. And then this filter is not used anymore, so let's remove that. And now we should get a bunch of places we need to fix here. So we'll go back on these ones. Backwards compatibility here. All right. Cool. Now what? I guess I'll try to run this and see what errors we get, because the LSP doesn't report anything. Autohash does not allow slices, well as unions and structs containing slices here because the intent is unclear. Considered autohash strat. Okay, whatever. Let's just use string. It's gonna, you're gonna get a, like when we change, if we change the key to something else later, we're gonna get a compiler anyway. So get state machine, yeah. So okay, so instead of auto, we're gonna use string. There we go. I think that was the issue. Okay. Force postpone. No field. Oh, right. Okay. So state machine. Right. So now we have like init here. Now the init function, I mean, okay, let's do this first. Let's change this to .init. That is really how we're supposed to call this here. See if we get other similar issues. Actually, I could just search for C state machine dot, actually like this. No? Okay, cool. And then, okay, play state machine debug. Has issues as well. Yeah, we don't have state anymore. So actually, this is interesting. I mean, we should probably just get state machine. Should this return the state machine or just the state machine in there, like the default state machine? Actually, I think this is the like the only place it's used. Let's just return like internal, and we'll return state machine by key, default key. Is state. Yeah. We need that as well. Okay. And that should probably be fine actually now since we changed this. And then same thing here. But this is the system, so we need to like change this as well. This is currently only updating the default state right now, so we need to kind of go through all the states and update them. But we probably need for is state, we need to do like by key as well. There we go. And then we get by key, and I guess, I mean, yeah. Should we allow this to be null? I guess. The only reason why I don't want it to allow for null is to catch situations where, I mean, I guess I could add a warning, like where you would forget to add a state to something. You could add like a warning, but that's not really that visible. It's just gonna show up as like some weird bug, and you're gonna have to search for why this happened. I think it's better to kind of assume that it has to be there. And this one just gets the default state, so that's, I guess that's fine for now. State machine 341. Okay, now we're here. So this will essentially, like, you provide an initial state. This is like init default basically. But the problem now is that this is an array hash map, and in order to add this initial state, we have to provide an allocation being able to happen here. So I think this needs to change now to so that we essentially say like append state machine with an initial state, and the state machine is, well, this, well, okay, yeah, and then we also need self. And this will essentially just call states put and we do need key as well. I'm just gonna say set state machine. No. What will this be called? Register, probably? I don't know. Register state machine. And we do need an allocator as well. And we have the key, and then we have the value. Can be init initial state. And we also actually need a dinit function here. If, well, it, yeah, sure, we need a dinit function. With an allocator. All right. Register state machine, yeah. So then here we probably we could add one that's called default that doesn't have the key, and instead of doing this, well, we'll do return register state machine. Wait, self dot register state machine. Whoops. There we go. Oh yeah, and then this is the default. There we go. The problem now is that we have to call this everywhere. What we could do is we could go to the state machine utils and add these functions, convenience functions here, where we can say register state default state machine. Actually, let's just do register state machine and we need a context. Okay. I guess, I mean, here, actually what we could do is we could make it so that we don't need to add it. Like, if this, so if we have a state machine, wait, this needs to be public. Yeah. By key. If this is, if we have it, we can use it. If we don't have it, we can create it that will say add actually, isn't there like get or add? Yeah, there is get or add. Let's implement that. Add or replace. Get or add. But that doesn't, yeah, you have to provide, you have to initialize it. Okay, fine. Yeah, because we don't know if we need to initialize it or not. But yeah, if we didn't get it, we need to add it. So this is going to be the state machine. Init. And actually, this doesn't work anymore. And we don't do that. It's just going to be init. And then we will get the state machine back out. Like that. So now this is either gonna get the state machine by calling this function, or we'll add it and then return it there. Wait. No, wait, that's the thing. Actually, we wanna do this. I just realized. Because this, yeah. Try get. And now that is a state machine. So either we get it there, then actually now we can call this here. So essentially what this is doing, like it will initialize the state machine component as well. So you only need to call this function. You don't need to add the state machine first and then call this function. So that's what I wanna That's what I'm after there. And then the initial state. Very good. There we go. And then we're gonna have also register default state machine. I'm contemplating whether to call this register state machine and then this register state machine by key instead, because that's the pattern we already had. So I'm gonna do that. And, yeah, let's actually do that by key, and then you will be just that. It might be better the other way around, but I don't know. Because default states that it's gonna be the default state machine. This is just like, yeah, a little bit ambiguous, I guess. And this will be by key. Key. Well, we actually don't know the key. Maybe I'll put this in a separate function in state machine. Get or add state machine. Oops. So we can also do this. I wish there was a way to do this inherently as well. I guess we could add this. I mean, I guess we could change this function to actually add like a default value here. And do the same thing here, like if we get t, we will get that and return that. C for component. Otherwise, we will add the default value and then return get t. Yeah. So now we don't actually need this function. We can just call get or add state machine, and then the default value will be just .init. And we can do the same thing up here. So now we don't need to know about default key here either. There we go. Okay. Now, what errors do we have? Forest boss 832. Right. So all of these now. So let's go back to the spawn here, because I did change this thing. So instead of doing this now, what we'll do is we'll do register state machine, and then the okay, actually we don't need the allocator because we have, actually yeah, we don't actually need to pass the allocator because we already have it in context. Nice. Okay. I just realized that. Okay, and then here we have force postpone state machine initial. And then we actually don't need to call this because that's going to be added there anyway. So now we simply need to replace everything like this. And actually we need to make sure everything is correctly done here. Whoops. Shooter, no, shoot. All right. Yeah, and then, you know, there should be like everything in monster, everything in device, everywhere we do this. So we can simply, let's do this, let's do like dot add state machine dot init. Wait. Okay, so all of these we need to replace. I could make a macro maybe. Well, okay. This is different though. This one is different. Yeah. Okay. And then, right, so we remove that. There we go. I see, this creates a new entity. Okay, so this one we could probably make a macro here. So I'll go to this, search for dot add. Register state machine. Context is gonna be that, and then the initial is gonna be another one, and now there we go in here. That's the initial, and then we remove you. Okay, let's see if that works. And this is one of the nice things about having patterns. When everything looks the same, it's a little bit easier to change into another pattern. Cool. And of course, we need to import this at some point. All right. See what else we get. Imagine this just goes through now. What the hell? Are you serious? Is it actually gonna succeed? I did not think that. Okay. Okay, let's try and go over to one of the monsters and see if they still work. Yeah. Cool. All right. Cool. So we have successfully now refactored the state machine system. So now we can potentially have multiple states and have them work at the same time. So although if we add another state, it's not actually going to be updated, because the thing here only takes the default state. So we have to make like an iterator for all the states, and we could do that. We could say, wait, why can't I go over here now? So we should be able to, well, we could do, where is it? Here. So if we get an iterator, which is going to be filter all dot iterator, right? Actually, we need the, I guess we need a do we need a filter? Or could you call iterator and then dot all? Yeah. And then the state machine is gonna be view get entity, because this view is a state machine view. Yeah. Okay. And then we'll do while iterator. Actually, let's call this IT. Next, we'll get the state machine there, and then we call the state function. There we go. So now we're looping through all those. Yeah. Okay, so that's that. The initialize. Actually, we could. Whatever. There's gonna be some memory leaks with the state machines. Actually, yeah. I just thought of something. Actually, we could use the ECS system as a hash map, actually. Instead of having our own hash map like this, we could just use, because then we don't need to worry about deinitializing. We could do like state machine keyed. I don't know. And this would be like a function, because this will be a unique type is the idea. And then you have a comtime string, which is the key. Yeah, I guess we can technically have it string machine or state machine key here. And this will return a type. And essentially it's just gonna turn like a state machine. I mean, yeah, it's gonna return like state machine. Let's do this internal. And then also, I guess we could keep the key around. I'm not sure. Or we could say pop-const key equals key, so we can like export it. Of course it's shadowing. There we go. So now it's like a unique type, because now it's like we could use, instead of having the state machine, now this could be one state, but when we register, instead of doing this, actually we won't have register on here. We will have it let's see, we will have it in state machine utils. So here we get that. Actually we don't get the state machine. What we do is we get or add state machine keyed, and then this will be the default key here, although yeah, so that will be that will be the idea anyway, because then we don't need to worry about the deinitializing of this hash map. Like we're kind of treating the ECS structure as a hash map instead. So actually we could turn this into a function. Like this. Returning a type. Because now it's like, because before I was thinking like I didn't want to do this, because before it was like, well, because the system can only, like it can't know basically what different types there are. But, and actually that's still true. I just realized that is actually still true. We yeah, okay, yeah, we can't actually do this without some shenanigans. Time shenanigans. Like what you could do is you could, because the issue is that the system still won't know to iterate through all the different types of state machine. So, but what you could do is keep a kind of time mutable around that will get updated as soon as we register a new state machine using a time known key, because then in the end we will know how many different keys there are. I think that's something you can do anyway. But anyway, let's go back to this here. And the problem is like this, the initialize function, like when do we call it? Because we had the same issue with whenever this component is like removed, you can have an event listener for that, but the problem is that there's a bug now, I think, in the ECS library that makes it so that you can't access the components in that function. So I think what I'll do is I'll add a function here which is like handle remove state machine, or handle destroy state machine, which, well, we don't really need the context, so I'm just gonna say this and then entity, and then we'll get the state machine if it's there. So this will get the state machine on the entity. If it's not there, we'll return. Otherwise, we will call the initialize with the allocator. I believe that's the allocator we need to use. Yeah. Let's just allocator. Like that. All right. Cool. Then I want to call that whenever we kind of destroy a entity or something. So when we destroy the entity, before we destroy the entity, I want to call handle something something, so that we hopefully clean it up basically at all times. There could be other places where we actually destroy as well, like over here. Okay, fine. Let's do this as well. And the other place where this could happen is whenever we actually remove a state machine from a thing. But I think that instead of actually just calling remove state machine, I think we just call this function actually, because in the end in the end we can just remove the state machine here from the entity, and there we go. So now it's like remove state machine. Let's just call this remove state machine. Yeah. All right. So we'll get this up and running. We will now, I think we have it working. So I'm just gonna double check the system. So the update, we'll call the update function. I was thinking the set state function as well. Set state, because that would call, yeah, set state for key we do have. So that would call the post function if it exists, and then change the state over. Call the pre function as well, I believe. Where is that? We call the post function. And we call the pre function if it exists. We set the thing to update, and we set the post function. Yeah. So then what we'll do now is we will say for the player, which has the mist form stuff, I want to move this logic down to a mist state machine. So we'll go here and we'll add a mist state machine. And we have an initial function, which is a function. This is probably like this, yeah. Context. Oops. Yeah. Okay. We also have the mist state, which is this. I'm just gonna copy that, put this over here. Initial will actually, we could add it here. We could add the mist state. Oh, it's either active or inactive. I guess it's inactive. That's the different states though. So I think we don't really need that. We just need this to be different states. So we'll have the inactive state, which has a cooldown. So it has to have a tree function. We'll set, actually no, before we do anything, I wanna import this file so we get the proper auto completion and stuff. PlayStation machine, I mean, we could actually just import it from here. And then add it here. No, we don't add the state machine. We will add, actually we'll register, that's right. Register by key mist. And the key we could also like, you know, state mist. Do something like that. And then this would be state machine initial. There we go. Although I don't think we'll want to have it here because this is like part of like this happens like I guess this will happen like the first frame. We probably want to move this out to the actual creation of the entity from outside. But whatever, let's just have it here from now. Okay, so now it should be part of the thing, I think. Or is this gamedev? Okay. All right, so now we're gonna set, no, so inactive, we're gonna, we could utilize the state utils here. there's like a default state duration. So set state duration, and this is gonna be just be the cooldown of the mist. So if we go over here and we'll have max duration, let's see, inactive. So this is the cooldown. Here's the cooldown. Let's copy these over here. So we'll have these. So we'll set mist form cooldown. That will be the duration of the thing. The thing is, like, even if we set it the state duration, we don't need to change the state even if the duration is up. What we do is we check if if has state ended, then we are eligible to go into active. But if it's not ended, then we can't really do anything. Welcome back, Penguin. Oh, I must have missed missed your message earlier. Sorry. I'm concentrated here. Yeah, and then we have the active state, which we can go to if we, so here's like if we're eligible to go to active state, and then we actually need to check, are we pressing the mist input key? Now the problem, though, I just realized with this system is that you're not always able to go into mist form. However, this could be something that is governed from outside. Now, I don't want to change the state directly, but what we can do is we can say that the mist state is actually, well, I actually want to make a new one. This is the old one. And it's gonna be a struct. And then this is gonna be like, is input on. So we'll have a bool that is like, this is turned on if the mist button is on this frame. But it will only turn on if you press the button, and if it's well, we can determine ourselves when this will turn on, because now we can get the mist state of the player, and we can turn this on whenever we need it to be on, basically. So, and then what this is going to do is it's going to listen to this state. So we're going to get the state, and we're going to say, well, if the input is on, if it's not on, then we don't care. If it is on, now we set the state to be active. And I just realized something else. This function, this context, needs now to have a key, actually. Yeah, so the state machines that actually has the key now actually we need to supply the key, because this context is like, we probably don't want the context to have the key. Probably not. This is gonna trip me up, because we need to add the key here. The duration is, yeah, that's also, no, this doesn't work. This doesn't work. This does not work. This is gonna target us. We only have one of these. That's not gonna work. Oof, this was a lot more, this was more difficult than I initially thought. But we could solve it by adding a timer here instead. So we could have like can missed at can activate, I guess. Whoops. Is there, wait. No. There we go. Oh yeah, now we can just set the state to inactive. Actually, we could put this here probably. All right. And we don't set the duration. What we do is we get the state and we say can activate missed at equals to create timer. Hello, Arzutsami. Yeah, I'm gonna wrap it up soon. I'm probably in like 10 minutes or something. How's it going? Let's see. So there we go. And now instead of checking this, what we'll do is get the state and we'll say if is timer expired, can activate missed at. So if it's not expired, we cannot do anything. If the state input is not known, we don't care. If otherwise, we actually transition into active. Yeah, there we go. All right, see you later, Penguin. Good luck. Okay, and then we have the active. The thing with active is we actually have two states here at once. So I think that we need three states. We need like activating, which is a separate state. And activating has a timer as well. And so we can say activates at. So when activating is entered, we set this timer. Activates at to be active missed form activation delay. And then here, if this timer expired, activates at, then we set the state to active. All good, all good. Nice, nice. Oh yeah, there we go. Okay. Yeah, and then active also has a timer, so this will be like when it becomes inactive, so ends at or deactivates at or something. So I'll go copy that, and then this is deactivate, missed form max duration. and then we change to inactive. There we go. Cool. So we'll go from inactive, we go over to activating, and then to active, and then mid state. And then this keeps track of all the things. It has like a bunch of convenience functions for can we activate, is activating, but can activate is now kind of governed by like we don't really need to check this. The only thing we need to do is to turn on this, which is like the intent to activate mist is on. What I'm gonna do also is that we probably, like, if we probably want to turn it off at some point as well, otherwise we will perpetually go into mist mode. So actually, like, when we go out of active or out of activating, we probably want to reset that. Is input on is false, and then same thing here. And this doesn't really matter, like, if we turn it off here, because we don't really check it here anyway. Okay. And then we have activate, we have deactivate, we have can activate, is activating, is activated. Yeah. So we could go, and here's the update function. Now this is just like on activate we add invincible, and also during update we draw a little rectangle. We update the color, yeah. So that's the thing, like so that can be replaced now. For activating, we can add, whoops, we can do this, add or replace invincible. No, not activating. That's gonna happen when it's active. There we go. And also we don't forget to remove it once we're done. So remove invincible. All right. Yeah. And then this part as well, which kind of debug, it shows the color of the thing. When we're activating, we should like add this. So like add the thing. Color is light gray, I believe I put there, maybe, or dark gray. I don't remember actually. Yeah, all of this gone. Right, there we go. The thing is, like, if we go out of activating, we probably want to remove this if it exists. Or if we go to pre-inactive, we probably want to remove it here actually. So remove if exists. This thing here. Yeah. All right. Okay, I think that's it actually. So now we can try to go back here and we can say, well, let's just not call this. This deactivates, which simply, oh, right, I forgot about this. Forgot about these things. I did forget about those things. Active, remove, if exists, I guess. Remove vanish. Yeah, vanish. We need to add vanish when we activate it as well. Or we need to add it when we activate it. And vanish has a duration, but we can say create timer instead of doing that. There we go. So we vanish only for the activation delay. I'm confused. No, this is when we act. This is the. No, so this should happen here. I see. So we're not vanished while in actual mist form. And we're also invincible. No, we're not invincible. We add invincible once we do activate, right? And then just change the color of the thing. But the vanish is only for when, like, activating, which doesn't make sense to me. That does not make sense. Okay, well, anyway, I can balance that later. This is not all fully thought out anyway. Okay, so we add invisible when active. We change the color to gray. When we're done, we remove vanish. Actually, this should then happen over here. But I guess you know what? Let's remove it here instead. We'll do the same thing there. We'll have the cleanup up here because you can potentially exit activating mode into. Yeah, so we'll have we'll add another signal here. Cancel activation. I'll add another signal that will check actually here. So if cancel activation, then we actually just want to set the state back to inactive and cancel this. And then we'll set this to false. I'll just set that to false as well. I don't know if that's going to have some implications though. It's like the same thing where you cancel. If you cancel and you press the button to activate mist form or something. You know what? Whatever. If it's going to be an issue, we'll deal with it. So I'll just remove this here. And I'll probably, yeah, we'll just move the cleanup into pre here. Yeah. Oops. There we go. All right. Cool. Okay, so now I think we have like everything here. So we'll remove you. And then there should be like update mist form we can remove. Right. Now these things, I'm not sure where they are used. Oh, we're using them here. Okay. So this is like, instead of doing this now, we activate mist form. Instead of doing that, we're gonna get the mist state. I'm just gonna do it like this for now. And we'll get the state, and then we'll set is input on to true. And then we don't call this, because this one is simply checking if we are inactive and we can activate. So that should already be governed by other things. So there we go. We just set it that the input is on. And we don't actually call activate. There we go. So we don't need the play component. We simply and also there's nothing really caring about the return value, so I'm just gonna remove that because it doesn't make sense. And here we can simply say we get the state. This input on is equal to if the thing is pressed. Cool. All right. So now we should be able to enter mist state from there. Let's go and check the other things. So this is not used anymore, so I'm just gonna remove it. Now deactivate is called if we're damaged. Now we're gonna do the same thing here. We're gonna get the mist state, and we're gonna say that we are trying to cancel this activation. If it's so, because this only happens if it's currently activating. So there we go. This could be something that is also like added. No, because we can only have one event listener at a time. Yeah. Anyway. Yeah, so that will try to cancel the activation if it's eligible there. Okay, so then the activate is now free of references, so let's remove that. Okay. Where is the mist state here actually? Oh, player state mist, that's right, there we go. So, do we have any references to this? No. Any references to you? No. You? No. You? Yes. Is stunned. Do we have any references to you? No. So let's remove you. And you. And you. And now we can just remove the whole thing. And we can remove the actual mist state as well. Nice. So we moved the whole thing over now to its own state machine. Now let's see if it actually works as well. And if this works, we're done today. For today. Oops. All right. 32. Oh yeah, you need state key there. Gotta make sure to really make sure that the actual state set state function is called with the key, because otherwise it will mess up a lot of things. Okay, we got nothing happens, and then we get a crash. Cool. Let's see. Debug. Entity. Yeah, so it did feel like it probably failed like after some time. Okay, we're trying to get the thing when we're active, and apparently this didn't exist, maybe then. So we are adding it in activating, and if it, and then we probably went back to inactive to remove it. Oh, I see. We're going straight into active. That's wrong. It should just go to activating. Also, there's interesting thing here where when the thing starts, we actually we called it. This should really just be called when you go into inactive from being like activating and inactivating before. I think we should have a separate state actually called like inactivating or deactivating, which is simply going to be a pre-function update is gonna like redirect to, so it's gonna do the same things, except here we're just gonna go back to inactive. That's all that's gonna happen. It's gonna be like a 1 frame delay there, but whatever. And then on inactivate, we actually don't really need to do anything. So this could just be actually be a function. There we go. Because then when we set the state initially, we don't get this thing here, which actually adds like a cooldown to the inactive state, or yeah, so that we can activate again. But now we actually need to change this to deactivating instead of inactive directly. There we go. Cool. All right. So let's try this now. Okay. There we go. Seems to work fine. Then afterwards there's a little bit of cooldown, and we can, you know, we can activate it at basically any point except when attacking. It's like anytime we call, I think it's like anytime we call missed behavior, that's when we can actually do it. So that's fine. We can determine like when we can activate it or not. Cool. All right, so that's, now we have like missed state that is like a separate state from the normal the default state machine. It's just that we have to remember that now it's like its own key, and we have to make sure, because you can actually say set state here to inactive, and if you do that, you're actually changing the default state of the player to be like the missed form. So it's like this will basically make the player not being able to do anything actually right now. So if I start like this, if I start now, I can't do anything. So we basically yeah, and it can't like find the actual thing, so it just shows the pointer information here. So yeah, so if I like do this mistake, although it's like easily, I guess it's easily it's easy if you see it like that. It's not easy if you do it to kind of the boss, perhaps, for example. Maybe we'll have a convention where we actually have a set state function, and the state and this will essentially be set state for key state key. Yeah, this is the new state. So instead of calling set state for key, we call set state, and have that as a convention instead, so that we don't need to supply state key every time. Yeah. Maybe. It's just I see that this could potentially lead to a lot of confusion here and weird bugs that take a long time to perhaps figure out because of this thing. But yeah, we'll see. And this is why I like to explore. I like to explore new things, new ways of doing things, trying to define different setups that kind of work, and see, you know, what works and what doesn't work. All right, but that's gonna be it for this time. So yeah, thank you very much for watching, and I'll see you probably tomorrow. Hope you have a nice day, and I'll see you later. Bye bye.